Hi everyone, this is Dr. Nishok from ECE Department, SNS College of Technology. Here in this video, we are going to see the design thinking activity on why bias stability matters in electronic devices. So in this presentation, we can see how the electronics engineer identify the user problem and what is the root cause of it and how, the solution for the problem and how it is tested and utilized and how it improves the electronic circuits performance. So this is the outline of our video. It starts with understanding the user, identifying the problem, brainstorm possible solutions, bias stability, voltage divider circuit, and real life applications. So here, if we connect a Bluetooth speaker, at the initial stage, it is playing in a nice manner, and when the device plays for a long time, later it starts to distort, output start to distort, and we are getting different sounds when comparing to the initial stage. Why does it happens? So let us understand the user. So imagine a user listening to a music. So in the initial stage, as said earlier, so we will be getting a clear sound. After a long time, so we will get the distorted sound. So that is noisy sound, and with low volume or high volume, the variations occurs. So the users will feel frustrated and poor listening experience, and almost he thinks the speaker is damaged. So we have understood that users experience. Then we are identifying from the user's problem, we are identifying the what happens in the device. The speaker is not actually damaged. The real problem is due to the prolonged time, the usage of the device. So the transistor may having characteristics variations like temperature variation, which makes the heat to increase, so that deviates the operating point, and finally it results in the bad amplification that shows the deviation in the output or noise. So for this identified problem, for the main cause is operating point variation. Because of that, poor amplification happens. This results in distortion. For this identified problem, the engineers initially identify the solve using the brainstorming possible solutions like better transistor. Either we can use better transistor or cooling system or better heat sink or stable bias circuit. So whatever may be the method, so whichever best suits to the problem, so that is identified using the brainstorming session. So as at the conclusion of the brainstorming session, the bias stability is decided as the best engineering solution. So here the bias stability circuit, by using the bias stability circuit, which maintains the operating point, Q point, it is mentioned as a Q point, to be in a stable point, that is in active region, so that the amplification will be in faithful manner, so there won't be any distortion or noise in the output of the signal. So we will get a good song whenever or how long the device is used. So that is the main advantage of using the bias stability circuit. So coming to the prototype model, so we can use the voltage divider bias circuit as for the bias stability. The voltage divider bias circuit consists of the two resistors R1 and R2 and one transistor along with the DC power supply. So along with these components, the circuit is built as shown here, so which provides a stable base voltage, keeps the transistor in the active region. So if the transistor is in the active region, the output will have the 100% full swing, so which results in the good amplification, which reduces the distortions and improves the performance. So next stage of the design thinking is test stage. So here the engineers team is comparing the circuit without biasing stability with the biasing stability circuit. So without biasing stability circuit consists of distortion. So because of distortion, output changes and poor performance of the circuit. So when coming to the bias stability circuit, so which because of the stable Q point, it improves the amplification and clear sound is obtained as a result, which is reliable operation here. So finally, the real life applications of this bias stability circuits are mainly used in different electronic products like mobile phones, Bluetooth speakers, television audio systems, home theaters, radio receivers and sensor circuits. So let's summarize here. First, the engineers team identify the user's problem and analyzes the root cause, and using the brainstorming approach identifies the different solutions and finalize the best solution, and based on the solution the prototype model is created and which was tested further for accurate result or verifying the output, and finally results in the user satisfaction. So as a conclusion, here in this topic, the temperature affects the transistor performance. So we are using bias stability that maintains the stable operating point, even the variations in the temperature or any other characteristics deviations. So stable operating point produces the faithful amplification. So better amplification results in the better output. So that is better user experience. So finally, small circuit like voltage divider bias circuit improves better output in the electronic products. So thank you all for listening this video. So as a conclusion, we can tell the design thinking approach provides the better real-time solution for any sort of electronic problems. Thank you.